The second algebraic method of solving linear systems is called elimination. So this can be used similar to substitution. You can use it for any linear system, but sometimes it is easier and more noticeable to use. When you are using elimination, most likely both of your equations are going to be in standard form. Okay, so one of your variables will not be isolated, and if you were to try to isolate your variable, you would get a pretty gross fraction. Sorry, this is going to be in standard form, so it will look like ax plus by is equal to c. Okay, so your x and y term will both be on the left side, and you'll have a number on the right side. So the steps to solving for elimination, it's a little bit more straightforward to see if you have an example. So I'm going to show an example here and kind of walk through it. So let's say our system is 3x plus y is equal to 19 is our first equation, and then 4x minus y is equal to 2. So the first thing that we are going to do here is we're taking a look at both equations, and we want to see, is there already a coefficient on either both x variables or both y variables that's the same, or can we easily multiply the equation by something to make the coefficient in front of your x or your y variable the same. Okay, so what I'm noticing here is I have positive y in my first equation. Okay, if I call this equation 1 and this equation 2. And then I've got a negative y in that second equation. So I'm noticing that both of those terms have a coefficient of y. One of them is positive, one of them is negative. But if I were to add them together, it would eliminate y. Okay, so that's why this method is called elimination, because we are going to eliminate or get rid of one of our variables. Okay, so what that's going to look like is I'm going to put a line underneath my system like this, kind of like if you were setting up a addition or subtraction question with just regular numbers. And what I'm going to do is, like I said, if I add plus y minus y, that's going to cancel out the y. So this line here, I'm going to do equation 1 plus equation 2. Okay, so I usually will write a plus sign down here, but it's also helpful sometimes if you just show it between all of your terms so that you know what you are doing and you don't make any little mistakes with calculating. Okay, so because these are already both in standard form, they are lined up with our like terms. So my x terms are stacked, my y terms are stacked, and my number terms are stacked, and you're just adding between each column. Okay, so 3x plus 4x gives you 7x. Positive y plus negative y just gives you 0y, which is going to just cancel out. I don't usually write that term there, but that's just to show you what happens there. Equal sign stays in the same spot, and then 19 plus 2 gives us 21. Okay, so now we have an equation 7x equals 21, and there's only one variable, x, so we can isolate for it. Okay, we couldn't solve anything before because there are two unknown variables, and you cannot isolate when there's two unknowns, but now we can because we have just 7x equals 21. Okay, I'm just writing it like that so you can see it a bit easier. Then to isolate for x, we're going to divide by 7 on both sides to cancel this out, and you have x is equal to 3. Then similar to the second step of substitution, you're going to just put that x value back into either one of your equations to solve for y. Okay, it doesn't matter which one you put it into, so I'm going to sub x equals 3. Let's just put it into my first equation. Again, it doesn't matter which one you put it into. So I'll have 3 multiplied by 3 plus y is equal to 19. And then I am just simplifying and isolating. So 9 plus y is equal to 19. I want y by itself, so I'm going to subtract 9 from both sides. And now I have y is equal to 10. And then I can just state my point of intersection, which is 3, 10. Okay, so that's how we do elimination. Again, it's kind of difficult to write out like a step-by-step procedure in words, but as you practice, it gets a lot easier to see how you set this up. So that was an example where both equations were already in kind of a good position to use elimination because the coefficients in front of y were already both 1, and one of them was positive, one was negative, so we didn't need to change anything about the system. We could just simply add and then start solving. So if we look at another example here, this is an example where we need to make some changes to the system before we can solve. So in this linear system, I can see both equations are in standard form, which is what I want. I have 3x plus 5y equals 15, and I have 2x plus 3y equals 10. So again, my first step is I'm looking to see, is there the same number in front of both of my x's or the same number in front of both of my y's? And in this case, if I look here, I have a 3 and a 2 in my x's, so those are not the same. And then I have a 5 and a y, those are also not the same. So I need to make some modifications to either one or both of my equations to make this so that the numbers are the same in front of either the x's or the y's, and then I can eliminate. So I'm going to call this equation 1, this equation 2. And it doesn't matter which variable you choose to make the same. I usually, if there's not one that's clear, like sometimes maybe this would be like a 10y, and then you can see, okay, well, 5 multiplied by 2 would make a 10. If it's not clear which one to do, I just always go with the x variable because it's in front. Okay, so what I want to do is I want to see, okay, can I multiply this equation, equation 1, by some number, and equation 2 by some different number to make it so that the number in front of both of my x's is the same. And the easiest way to do that is by multiplying equation 1 by the number that's in front of x in your second equation, and multiplying equation 2 by the number that's in front of x in your first equation. Okay, so what that looks like is I would do equation 1 multiplied by 2. And when you do that, you are multiplying all 3 terms by 2. Okay, if you only multiply the first term, then you are changing the equation of the line, which is not allowed because that makes it so that it's a completely different line. But if you multiply the entire equation, all 3 terms by 2, then you're not changing the line at all, you're just making the numbers bigger. But if you were to graph that line, you would have the exact same line as what is written for equation 1. Okay, so if we're multiplying by 2 here, then we would have 6x plus 10y is equal to 30. And then I'm going to take equation 2 and I'm multiplying it by the number in front of x in my first equation. So I'm going to multiply it by 3. And again, all 3 terms get multiplied by 3. So 2x times 3 gives me 6x. 3y times 3 is going to give me 9y. And then 10 times 3 is going to give me 30. Okay, so now I see that I have a 6 in front of this x term and a 6 in front of this x term. So that was my goal, was to get the same number in front of either my x's or my y's, because now I can eliminate. Okay, so I'm going to just call this equation 3 and this equation 4, just for the sake of labeling, okay? So now what I'm going to do is I'm going to put my line underneath of here, and I'm taking a look to see what do I need to do in order to eliminate. So in the previous example, we added the equations so that we could cancel out the y term. However, here I have a 6x and a 6x. They're both positive. So if I were to add my equations and put my plus between each of these ones here, then I would have 12x and 19y. And in that case, your variable doesn't get eliminated, so it doesn't help you in any way. You are no closer to solving. However, if I subtracted the equation, so if I did this equation here, equation 3, subtract equation 4, I would have 6x subtract 6x, and that would eliminate my x variable. Okay, so that's what I'm going to do instead. I'm going to subtract, and again, I'm just going to show this between each of my 3 terms so that I'm making sure I'm not making any small mistakes here. Okay, and I'm doing equation 3 subtract equation 4. So I'm doing 6x minus 6x. That gives me, again, 0x, which I don't usually write. I just know it cancels out, but if you would like to write it, that's fine. 10y subtract 9y gives me 1y, so I can just write y. And then 30 subtract 30 gives me 0. Okay, so in this case, it's telling me y equals 0, which is fine. It's okay if one of your coordinates is 0. That's still fine for a point. It just means we don't have to do anything else to isolate here. Okay, so the way that you decide if you're going to add your equations or subtract them is you're just looking to see what will actually eliminate the variable that you're trying to eliminate. Okay, so in this case, like I mentioned, if we were to add the equations, it would not eliminate the x variable. It would give us 12x, and we would still have 2 variables, which is not what we want. Okay, so you are either subtracting between all of the terms or adding between all of the terms based on what will eliminate either your x variable or your y variable. Okay, so now that I have y isolated, I am going to sub that back into either one of my equations. And you actually have 4 equations now that you can sub into, so it doesn't really matter which one. You can sub it into one of the original ones, or you could sub it into one of the multiplied equations. Doesn't really matter. I usually go back and sub it into one of my first equations just because the numbers are smaller. But again, doesn't matter which one you choose. I'm going to sub it into equation 2 just because it looks to me like it's easier to isolate. So then we will have 2x plus 3 times 0 is equal to 10. 3 times 0 is just 0, so that's gone. So I'll just have 2x equals 10. Then I divide by 2 on both sides to fully isolate, and I have x is equal to 5. And then, as always, my final step is just to state my point of intersection as a coordinate, making sure that I'm writing it with my x coordinate first and then my y coordinate. Okay, so again, in this example, we found the y coordinate first, but that doesn't mean we write it first in the point of intersection. We always write the x coordinate first. So 5, 0, and that is your solution for that example.